Hello, this will be a demonstration of Proposition 26 from Book 6 of Euclid's Elements, which says that if from a parallelogram there be taken away a parallelogram which is similar and similarly situated to the whole, and having a common angle with the whole, it is also about the same diameter as the whole. We're given a parallelogram A, B, C, D. A, B, C, D. And then from it, we're going to take away another parallelogram which is similar and similarly situated to the whole. Okay, something like that, let's say. And this is going to be the parallelogram A, E, F, G. And this parallelogram EG is going to be similar to the parallelogram AC. What we're going to prove is that these two parallelograms, AF and AC, have the same diameter, so that the straight line AC passes through the point F. For if this is not the case, then the straight line AC is going to pass through some point which is not F, so it's going to pass through some point, let's call it H. Like that. And this is going to be the diameter of the parallelogram ABCD. Next, we're going to produce the straight line GF down to the point H, like so, by postulate 2. And through the point H, we're going to draw the straight line HK parallel to AD or BC. We can do that by proposition 131. This is going to be the straight line HK. And HK is going to be parallel to AB and BC. Now, the parallelograms AC and AH sharing a diameter, we assume that in the first step. It then follows by proposition 624 that the parallelograms about the diameter of the same parallelogram are similar to the whole. Follows that DA is to AB just as GA is to AK. But we were given that the parallelogram AC is similar to the parallelogram EG, which means that DA is to AB, just as GA is also to AE, which means we have two ratios which are the same with the same ratio, which means by proposition 511 they are the same with one another, so that GA is to AE, just as GA is to AK, for both of those are the same ratio as DA to AB, so GA is to AB, GA is to AE, just as GA is to AK, and magnitudes to which the same has the same ratio are equal to each other, that's proposition 59, so that because GA is to AE, just as GA is also to AK, AE is then equal to AK. But it is manifest that AE, being a part of the whole AK, is therefore less than it. So AE is simultaneously equal to and less than AK. This is patently absurd. And so the parallelograms AC and the parallelogram AF cannot fail to have the same diameter, which means that they do have the same diameter. And this is what we set out to prove, which means we are done with the proposition, therefore, etc. QED. I've got nothing to say about this proposition. There's nothing about this proposition that doesn't explain itself. So I'll end the video here and move on to proposition 627.